Op-amps, non-inverting amplifier and specifications, prepared for collaborative creation of OER by team RC1331005. The target audience is second year, third semester engineering students. In this section, we shall focus on the expressions for input and output impedance of non-inverting amplifier, then move on to a major application of non-inverting operational amplifier, and finally we shall discuss a numerical based on non-inverting amplifier. To start with, the input impedance of an operational amplifier circuit is given as Zin 1 plus open loop gain AOL times beta times Zi, where AOL is obviously open loop gain of op-amp, Zi is the input impedance of op-amp without any feedback, and beta is the feedback factor. For a non-inverting amplifier, the feedback factor is given as beta is equal to R1 divided by R1 plus R2. That is, beta is 1 upon closed loop gain ACL. Therefore, for a non-inverting amplifier circuit, the input impedance is given by the equation Zin 1 plus open loop gain times closed loop gain whole times the input impedance Zi without any feedback. Next, we come to output impedance. The output impedance of an op-amp is expressed as Zout is equal to Z0 divided by 1 plus open loop gain times beta. Z0 is the output impedance without any feedback, and beta, as usual, is the feedback factor, and AOL is the open loop gain. Since beta is 1 upon ACL for non-inverting amplifier, the output impedance is expressed as Zout is equal to Z0 divided by 1 plus open loop gain times closed loop gain. Next, we come to one of the major applications of operational amplifier in non-inverting configuration, the voltage follower circuit. Voltage follower circuit is one of the simplest uses of an operational amplifier. The output voltage is exactly same as the input voltage applied to the circuit. The gain of a voltage follower circuit is unity. The output of the op-amp is directly connected to the inverting input terminal, and the input voltage is applied to the non-inverting input terminal. The voltage follower has very high input impedance and very low output impedance. The circuit diagram of a voltage follower is shown below. This is the op-amp with inverting input being directly connected to the output without any feedback resistor, and the non-inverting terminal is provided the input, and the output is taken across this port. It can be seen that the above configuration is same as the non-inverting amplifier circuit, with an exception that there are no resistors used. The gain of a non-inverting amplifier is given as 1 plus R2 by R1. In the voltage follower, resistor R2 is equal to 0 and R1 is infinite. So the gain of the voltage follower is equal to 1. A voltage follower is commonly called unity gain buffer. The voltage follower or unity gain buffer circuit is commonly used to isolate different circuits, that is to separate one stage of circuit from another, and also used in impedance matching applications. In practice, the output voltage of a voltage follower will not be exactly equal to the input voltage applied, and there will be a slight difference. This difference is due to the high internal voltage gain of the op-amp. The open loop voltage gain of an op-amp is infinite, and the closed loop voltage gain of the voltage follower is unity. This implies that by carefully selecting feedback components, we can accurately control the gain of a non-inverting amplifier. Now we come to a numerical example of a non-inverting amplifier. We are expected to calculate the gain of the amplifier closed loop gain, that is ACL, the output voltage, the current through the load resistor IL, and the output current I0. Let's first take a close look at the circuit. The op-amp is in non-inverting configuration as the input, which is 0.8 volts applied to the non-inverting terminal. Then the inverting input terminal is connected across the ground through resistor R1, which is 10K. The feedback resistor R2 is 20K. And a load resistor 2K is connected across the output. The output current is designated as I0. The feedback current that flows in is I1, which flows through resistor R1 and finally is grounded. And the current through the load is known as IL right now. So let's start with the solution. The potential at node B is Vn, and because of virtual short, Va is equal to Vb is equal to Vn. Let's go back to the circuit A, B. Now, node A is at virtual short. So, whatever voltage appears at B will be appearing at A. Hence, we say the voltage across at point B will be equal to voltage at point A, which is equal to 0.8 volts. The current I1 is given by VA by R1. I1 is VA, the voltage across this resistor, this minus this, as this is grounded. So VA minus 0 divided by R1. So I1 is VA divided by R1. That is 0.8 by 10K. So it is 80 microamperes. Since the input current is 0, the same I1 must flow through the resistor RF or R2 as in the figure. So the gain of the non-inverting amplifier as per the circuit, the expressions that we have derived, the closed loop gain is given by 1 plus RF by R1, or as earlier we have referred, R2 by R1. So that is 1 plus 20 by 10 kilo ohms. So closed loop gain appears to be 3. The output voltage is given or derived from the closed loop gain itself, as the closed loop gain is the ratio of V out to V in. So V out will be the closed loop gain times V input. So 3 times 0.8 volts, that is 2.4 volts. Next, the current through the load resistor IL is derived from the output voltage and the load resistor. So output voltage appears to be 2.4 volts. So it is 2.4 divided by the load resistor value 2 kilo ohms. That is, the load current is 1.2 milliampere. And finally, the output current I0 will be the sum of I1 and IL. So it is 80 microampere plus 1.2 milliampere. That is 1.28 milliampere. Here we stop. And before closing this section, we would like to take the summary of what we discussed about non-inverting amplifier. A non-inverting amplifier uses voltage divider bias negative feedback connection. The voltage gain is always greater than 1. The voltage gain is positive, indicating that for AC input, the output is in phase with the input signal, and for DC input, the output polarity is same as that of the input polarity. The voltage gain of non-inverting op-amp depends only on the resistor values and is independent of the open loop gain of the op-amp. The desired voltage gain can be obtained by choosing the appropriate values of the resistors. The references are Chapter 10 of Electronic Devices and Circuit Theory, 10th edition by Robert L. Bollisted and Louis Nationalski. Non-inverting operational amplifiers from www.electronicshub.org, and Chapter 8 of Electrical and Electronic Systems of Pearson Education Limited, 2004. Thank you.